Throughout this entire unit, we've basically been doing some theoretical calculations with rational expressions. And what we're going to do today is we're going to look at a couple of different types of problems you could solve using rational expressions. And the first type of problem is a distance speed problem or a distance velocity time problem. Some of you in science have seen this triangle to help you with distance velocity time problems. For those of you who have forgotten, d equals vt, distance equals velocity times time. So this speed and velocity are the same thing in this situation. So you do need to know this problem or this formula to help you solve these types of problems. So the first thing we're going to do is we're going to read this problem. Once we've read the problem, we're going to take the information and set it up in a table. And then we're going to use our table to write a rational equation that we can solve to help us answer our problem in this situation. So in this situation, we've got someone who's doing an endurance race. They're going to cycle 120 kilometers and then they're going to swim 12 kilometers. They tell us that their cycling speed is 8 times faster than their swimming speed, and the total time to do the race is 9 hours. So the three columns that we're going to create in this particular table are distance, speed, and time. And if you don't like the word speed, you can change this to velocity because that's probably more common to what you've seen in science. Now, the two things we're doing is cycling and swimming. So we're going to use this table to help us pull information out of the problem and set up an equation. So the distance we cycled, well, we cycled 120 kilometers. How far did we swim? We swam 12 kilometers. Speed, well, we're going to say our speed for swimming is s. And it says that our speed for cycling is 8 times faster than our speed for swimming. So our speed for cycling is 8s. So what we do is we use distance and speed, or distance and velocity, to calculate time. And if you look at your little triangle here, it tells us distance divided by velocity is going to give us time. Or if you manipulate this formula for time, you're going to get distance divided by velocity is time. So our expression for time for cycling is 120 over 8s, and for swimming is 12 over s. Now, we're going to use these two expressions to help us form an equation. It tells us in the problem that the total time to complete the race is 9 hours. So if I take my time for cycling plus my time for swimming, that should give me a total of 9 hours. So there's our rational equation, very similar to a rational equation you've seen already. So now we're going to use this equation and solve it to help us find s, our speed. Now remember, the first thing we always have to do is state our restrictions or our non-permissible values. In this case, s cannot be 0. We're going to get rid of our fractions by multiplying every single expression here by 8s. So in the first case, the 8s's are going to cancel out and you're left with 120. The s's cancel out here and you're left with 8 times 12. And in the third case, you're left with 9 times 8s. Okay, so if we work this out, what we're going to end up with is 120 plus 96 equals 72s. Well, 120 plus 96 is 216. That equals 72s. And if we divide by 72, you're going to find out that s is 3. 3 is not a non-permissible value. Excuse me. But what does 3 represent? 3 represents speed. And speed in this particular question is going to be kilometers per hour because our distance is in kilometer and our times is in hours. So this tells us s, which is our speed of swimming. Our swimming speed is 3 kilometers per hour. And our cycling speed is 8 times that. So cycling, 8 times 3 gives us 24 kilometers per hour. So we're able to use a rational equation to help us solve a problem. We're going to look at a second problem here. The second problem involves a student council that's traveling from Knoxtown to Harperville for a conference, and they have two options for this particular conference. They can leave by bus tonight, or they can save 3 hours and leave tomorrow using the express train, which goes 25 kilometers per hour faster. So the first thing we're going to do is we're going to set up a chart. We know we can travel by bus and we can travel by train. And we've got distance, velocity, and time. So the distance that they are going to travel, it tells us up here the distance between these two places is 1,500 kilometers. Velocity. Well, we don't know the speed of the bus, so we're going to call that x. But we know that the train goes 25 kilometers per hour faster. So this is x plus 25. So we can take distance divided by velocity to come up with expressions for time. And it says that if they take the express train, they're going to save 3 hours. So that means the bus goes slower. So that means if I take the time for the bus and I take away the time for the train, that should give me 3 hours difference. So that's going to help me set up my equation. It's going to be 1,500 over x minus 1,500 over x plus 25 equals 3. Now our restrictions are that x cannot be 0 and x cannot be negative 25. So now I have to multiply each of these expressions by x and x plus 25. So in the first case, the x's cancel out and I'm left with 1,500 times x plus 25. In the second case, the x plus 25's cancel out and I'm left with negative 1,500 times x. And in the last case, you have 3 times x plus 25. So if I actually go ahead and expand things here, if I multiply them out, I get 1,500x plus 1,500 times 25. I think that's 37,500 minus 1,500x equals 3x times x is 3x squared, and 3x times 25 is 75x. So if I move everything over to the right-hand side, I'm going to have 3x squared plus 75x minus 37,500. There's my quadratic. And I need to factor this. Well, the first thing I can do to factor this is I can take out a 3. And that leaves me with x squared plus 25x minus 12,500. And if I find two numbers that multiply to negative 12,500 and add to 25, those numbers are x plus 125 and x minus 100. So if I solve this for x plus 125 equals 0, so x equals negative 125, and in the second case, x equals 100. If we look at these two solutions, 100 and a negative 125, x represents velocity. Well, I can't have a negative velocity in this case. So I know that my velocity of x is 100 kilometers an hour. That's my velocity of my bus. And if I add 25 to that, I get the velocity of the train. Now, it says how long would it take to travel by express train? So that's time by express train. So if I take 1,500 divided by 100 plus 25, which is 125, I find out that it's actually going to take 12 hours to go by train. Just by dividing these out, it tells me my time. So we've had two examples of distance, velocity, time problems. Now they're not the only problems. This is an extra example. It's related to solutions. You should have gotten this handout from your teacher, and if not, I'm going to have a copy of it posted on the class wiki so you can print it out. So this is additional notes that aren't in your workbook. So in this case, we're taking antifreeze and we're adding it to water. If you know a little bit about an automobile, it has a radiator that helps keep the engine cool, and you have to put antifreeze in the water in the radiator so it doesn't freeze in the winter. So they're asking us, if we have 12 liters of water, how much antifreeze has to be added so that we have a 40% antifreeze solution? All right, so to come up with the solution to this, we're going to use some proportions or some fractions. We know 40% is 40 out of 100. And we know that when we do the antifreeze solution, we have to set up a proportion that's equal to 40%. So we know that we're adding antifreeze. So we're going to put antifreeze as X. We know we have some quantity of antifreeze plus 12 liters of water. And if you divide this out, it should give us a fraction that is equal to 40%. Now we have a fraction equal to a fraction, so we can actually cross multiply in this situation. If we expand, we get 400x plus 4800 equals 100x. If we subtract 100x from each side, we get 300x plus 4800 equals 0. If we subtract 4800 and divide by 300, I believe we get 16, or sorry, negative 16. Hold on, that doesn't seem right. Let's check something out. I see where my problem is. My problem is back up here. 40 times x plus 12 is not 400, it should just be 40. So we have to adjust this. Sorry folks, I had one too many zeros in my solution here. Okay, so let's go back and let's look at this. 40 times x is 40x, and 40 times 12 is going to give me 480. Now if I subtract 40x, I get 480 equals 60x, and if I divide by 60, I get x to be 8. That's better. X is the amount of antifreeze, and you can't have a negative quantity of antifreeze. So what this is telling us is the amount of antifreeze we need to add is 8 liters of antifreeze. Has to be added to the 12 liters of water to generate a solution of 40% antifreeze. And if we compare this back to the original question, if we put 8 in for x, 8 plus 12 is going to give us 20. And if we simplify this, this does in fact give us 4/10 or 40%, which is what the solution needs to be. So there's our check. So basically when you solve a solution problem, you need to create a fraction for the percentage in the solution, and then you need to create another fraction for the item you're adding and the total quantity you will have in the solution. So there we go.